In this experiment, we attempt to reduce an aldehyde or ketone to an alcohol. The reducing agent is sodium borohydrate. In this experiment, we were given sample 4A, which has a molecular formula of C13H10O. The number of moles needed from the sample was 0.012. This was calculated to be 2.19 gram, where in the actual experiment 2.20 gram was used.
The Wade reactant was dissolved in methanol. It dissolves in methanol because the functional group was polar, so it dissolves in methanol, which is also polar. Sodium borohydride was added slowly to the solution via BOH. Sodium borohydride is a very powerful reducing agent, so would reduce the functional group on the reactant. About 30 ml of hydrochloric acid was added to the solution to neutralize any remaining sodium borohydride. The reaction gives off hydrogen, which is why it foams.
To the solution, 50 ml of diethyl ether was added and the mixture was shaken in a separating funnel. There, the alcohol product moves into the ether layer while a lot of the impurities remain in the other layer, which is filtered off. At this stage, impurities that dissolve in water leave the ether layer and the water is again filtered off.
Magnesium sulfate is hygroscopic, so absorbs any remaining water in the solution. It is apparent when all the water has been removed, when you get a snowstorm effect rather than clumps of magnesium sulfate. The magnesium sulfate is then removed with filter paper. Rotary evaporators are used to remove the solvent or reduce its volume. It does this by creating a vacuum, therefore reducing the pressure, and if necessary by heating the round bottom flask.
From the infrared spectrum of the product, it can be deduced that there is a broad OH signal at 3273 wave numbers. Absorbance in the 3200 to 3500 wave numbers is characteristic of an OH peak because this corresponds to the vibration of the OH bond.
The nuclear magnetic resonance spectrum of the reactant shows definite benzene peaks with no other hydrogen environments. This suggests a ketone. The product NMR spectrum shows the benzene peaks and two other proton environments. This suggests the structure shown.